To create your first Arduino program, open the Arduino IDE. IDE stands for Integrated Development Environment. An IDE is a software tool that combines code editing, debugging, and compiling in one single interface. Once the Arduino IDE opens, you can see a lot of options in the interface. Let us look at the main features of the IDE. On top left of the IDE, there are 3 buttons and a drop-down menu. The first button helps us to change the code from human-readable language to a language which Arduino can understand. This process is known as compiling. The second option uploads the code to the Arduino board. The drop-down menu will be useful for selecting the Arduino board and port after connecting the board to your computer. A port acts as interfaces between the computer and external devices like Arduino, allowing seamless communication between them. For a text editor like Notepad, the files are known as text document. Just like that, our Arduino file is known as an Arduino sketch. This editor will help us to edit our Arduino sketch with many options like code highlighting, checking for errors, code suggestions, etc. Now let's start creating our first Arduino sketch. The Arduino code is a variant of C++, which is a highly used programming language. Let's look at each line of code step by step. Every Arduino sketch contains these 2 blocks of code. They are the void setup and void loop. Let us understand what they are. Void setup is a function or block of code that only runs when the Arduino is powered up. It means that whatever we give inside the void setup function will only run once when the Arduino is powered up. Then it will never run again. This can be useful for setting up some of the sensors and motors, which doesn't need to be done again and again. Next, let's look at the void loop function. As the name suggests, the code inside the void loop function will be executed over and over again until the board is turned off. This is where all our code logic and process are happening. Take an example of a robot which continuously checks for its surroundings. This can be achieved using void loop, as the code inside it will run again and again. Now we have understood what void setup and void loop are, so let's use them for creating a simple blink program. Before creating the code, let us understand how an LED blinks. First, an LED should be turned on. Then it should stay on for a fixed period, like 1 second. Then it should turn off and wait for another 1 second. This process should run forever to create a blink program. For creating the circuit, we will be using an LED, a resistor, a breadboard, and an Arduino Uno. First, connect the LED to the breadboard. Then connect one end of the resistor to the same row as the positive terminal of the LED. So for this circuit, we will be using pin 8 of Arduino. Connect pin 8 to the other end of the resistor. Last, connect the negative terminal of the LED to the GND or ground pin of the Arduino. We have completed the circuit. Let's start off by programming the void setup function. For the Arduino to understand that we are using pin number 8, we have to explicitly program it to say that we are using this pin to turn on and off an LED. Turning on and off is an example of an output pin. This type of pin can only change the state of that pin, like turning on or off something. Another type are the input pins. They have the ability to only take data from outside to inside. Examples of using input pins are sensors. Sensors gives us data instead of taking data, so we will be using input pins. Now, for our program, we need to use pin 8 as the output pin since we're turning on and off an LED. To give this type of instruction, we have a function called pin mode, which can change a pin to output or input. After you type pin mode, add a bracket followed by the pin you want to change. In our case, it is pin 8. Then after putting a comma, give the type of pin, which in our case will be output. End the function by closing the bracket. Always remember to finish a line of code by putting a semicolon. That's all we need to do in the setup part. Next, for our loop function, we will create the same workflow which we discussed earlier. Turn on the LED, wait for a second, turn it off, wait for another 1 second, and repeat this forever using our loop function. To change the state of an LED, like turning on or off, we have a function called digital write. First, add a bracket to open the function. Then, give the pin which you want to change the state, like is pin 8, add a comma, and finally give the state, which can be high or low. High stands for turning on, and low stands for turning off. We want to turn on the LED, so put high, close the function, and add a semicolon. Next step is to give a delay. We can do this by using the delay function. A delay function takes a single parameter, which is the number of milliseconds, to wait. Open the bracket and give the delay in milliseconds. We want a delay of 1 second, so give 1000 milliseconds. Close the function and finally put a semicolon. Next, repeat the first step, but only change the state to low, which means turn off the LED. Use the digital write function. Give the pin number and then the state of the pin. So digital write pin 8, low. Next step is to give a delay. Open the bracket and give the delay in milliseconds. We want a delay of 1 second, so give 1000 milliseconds. Close the function and finally put a semicolon. We have completed the program. Use the upload button to upload the code to your Arduino. Don't forget to select the right port and board using the drop-down. We can see that our LED is now blinking just as we programmed it to do. Remember that Arduino code is case sensitive, which means that pin mode with M as small letter will not work. Always give M as capital letter for proper functioning of the code.